Alright, so to continue my demonstration, this is the source code I used. I used Python, and these are my libraries. I use Leap, Microsoft, NumPy, Math, Time, PyPlot. So, yeah. I create a couple matrices for changing around variables. And I use a couple classes. My first class is transpose. This is basically holds all my information about the transformations and lets me manipulate that data. This right here, that just takes it's part of the transpose for a revolution, and this just takes the P, that part of the matrix, so it just takes off that. This is my effector. Basically, I'm modeling where the end effector is, so I take all the data for where an end effector should be. Like I got my X, Y, Z, pitch, roll, yaw for that end effector, so basically position and orientation. This function right here does all my inverse kinematics. I use the effector to find its position, my px, py, pz, and its distance r. I use that to solve algebraically where all my what all my degrees should be for the joints, what my theta is, and basically that stalls all that and then returns those degrees. This function right here, this does the forward kinematics going from the base to the end effector. Talk about it more when I get to my main function. I'm not really using this. This is when I tried to animate it, so I could pretty much just delete this, but I don't know. I might try and animate it, but I can't do it. So yeah, so this is my main. Basically it waits for a key to be hit, and then it starts running. Takes in, it uses the inverse, theta inverse. Yeah, I use my inverse kinematics to find theta, and then I convert them to degrees and print it out. And then I use my I use all the transpose information back in the transpose class, and I insert that into here to do the forward kinematics. Important thing was I also had to take the endpoints of each transform. So here I have, so that way when I'm plotting it as a way to start. And this is where I just plot everything. I have two plots, one for my X, Y, and my Z axis. And that's pretty much all my code. If you want to go back to the forward kinematics here, basically I do it, I have T, like this will be kind of like a normalized time step. Res is my resolution, like how many integers I want, or points I want in between 0 and 1, and then I multiply that by my basically my transpose times the P. And for my transpose, I'm taking basically I'm like setting it to 0, so I have T0, 0, 1, and I multiply that for my input, so I get a transform. Like for my end effector, I get T of 0, T06, T06 or 06 transpose. And that will get me my point to be able to reference it, so when I plot it, I don't just have a bunch of lines everywhere, they're all connected. And now I'll show you my program, or I'll show you that in the next video.